What we're going to talk about today is an introduction to chemistry. And chemistry is really the study of matter. Matter is composed of atoms. And these atoms, which are basically these little building blocks that on a large scale make up everything we see, come in different flavors, we'll call them flavors, which are really called elements. Are essentially the different flavors that atoms come in. Some examples of these different flavors include things like oxygen, hydrogen, um, nitrogen, and helium. These are the different kinds. Just four examples of different kind of flavors that atoms can come in, or elements. These are examples of the elements. The full list of elements that we have in our universe can be found on the periodic table, which tells you all the different kinds of elements and the different properties they have. Now, things like oxygen. Let's have a small representation of this. Will be oxygen. You'll have these little oxygen atoms. If you had hydrogen would be comprised of these little hydrogen atoms. Obviously, they're not really little circles in real life, but I think it's a little bit of a good simplistic representation of what we need to talk about. Now, certain atoms like to arrange themselves in specific orders, specific ways. For example, things like oxygen, their atoms will like to double up. They'll like to become pairs, specifically in twos. Hydrogen and nitrogen also like to do that exact same thing. They'll pair up in twos. On the other hand, things like helium, they don't do that. They just stay single. They just like to float around on their own. They don't like to pair up necessarily. Now, when you have atoms that are paired up together in twos, things like these two oxygen atoms paired together, when they're attached in this manner, we call them a molecule. And a molecule really is just any arrangement of atoms when they're attached together. It could be 2 atoms, 3 atoms, 4 atoms, as long as there's 2 or more atoms. It could be the same atom, it could be different atoms. As long as there's 2 or more atoms attached together, we now designate that microscopic little building block as a molecule. It's a molecule composed of 2 atoms. So this molecule has in it 2 oxygen atoms. Okay? Again, these would be hydrogen molecules, these pairs. These would be nitrogen molecules, these pairs. And then these would not be helium molecules. These would be helium atoms. Again, these are not helium molecules because they're not attached to each other. Because the way helium works is that it likes to stay on its own. So, what's the importance of this? So, on a macroscopic scale, everything we see is composed of either atoms or atoms that are connected together. We call them molecules. And that gives us different kinds of substances. So a good example of this would be something like bromine. So we'll talk about bromine. So bromine also likes to pair up, like we saw oxygen does. So you'll see bromine will pair up like this, and we write that down on paper as Br2 with a little subscript 2. Same way oxygen would be called O2, because there are 2 oxygen atoms for every molecule, so too bromine also, there are 2 bromine atoms for every molecule. Now if I had a cup, sorry for the terrible lines, not exactly a world-class artist, but if we had a cup and we filled it with bromine, which is a liquid at room temperature, what we'd see is just essentially this liquid of bromine. Um, but inside, what it would be made of is trillions and trillions and trillions and trillions of these little pairs of bromine atoms called bromine molecules. And that's really what would comprise this liquid. On a macroscopic scale, we call something like this liquid, a pure substance, because there is nothing else but bromine atoms in this container. A similar example would be helium. Let's say we had helium. So helium, again, we said does not form molecules. Rather, the atoms float around on their own. They don't like to pair up. So if we had a container that contained this helium like this, it would also be called a pure substance. Even though over here it's not made of molecules, still it's a pure substance because there's nothing but helium in that container.